cycle. And my formula for period is 2 pi over k. Can someone tell me what my k value is in this particular equation? What is my k value? What is the number that I factored out? Roxana, what's my k value? What number did I factor out? 1/2. Yes, so 2 pi divided by 1/2. And when you do that, that's the same as 2 pi over 1 multiplied by not 1/2. We flip the reciprocal, it becomes 2 over 1. So this is equivalent to 4 pi. And our phase shift happens with the brackets. Remember, it's always opposite. If I have positive pi inside the bracket, my phase shift is pi units not to the right, but to the left. The final element that I want you to analyze, when we look at our vertical transformation. Remember, for the cosine function, the axis of symmetry that divides the graph in half for the original function. If we go back to our original cosine function, and also for the sine function, but we're going to look at the cosine function in this case, our axis of symmetry that completely divides the graph in half is the x-axis. In this case, x is equal to 0 is the axis of symmetry. Now, whenever we have any type of vertical transformation, not horizontal transformation, right, because horizontally that will not affect the graph, but if it's a vertical shift up, then my graph would shift up. My axis of symmetry would shift up. However, because this is a vertical shift down by -1, my axis of symmetry is going to shift down. So whatever your vertical transformation is, your axis of symmetry is going to be equivalent to that value. So my axis of symmetry for this particular question is going to be x is equal to -1. Now finally, just from the factored form of the mapping relationship, I can determine, from the factored form of the transformation equation, I can determine a mapping relationship that I can apply to the 5 key points in order to generate the points of my new graph. So, using my highlighter, first I'm going to determine what affects my my y-intercepts first, because that's the easiest. So vertical stretches and compressions always affect, we multiply that by our y value. Sorry, this is a +4 in this case. So I'm going to multiply my y coordinate by whatever my vertical stretch or compression is, in this case +4, and then I'm going to subtract my vertical shift. So I have 4y minus 1 is going to be the mapping relationship for my y coordinates. For my x coordinates are affected by everything that affects the graph horizontally. So horizontal shifts and stretches and compressions, and horizontal shifts. In this case, I have to take my x coordinates and divide them by 1/2, and after that I can subtract pi from my x coordinates. But that doesn't look very neat, so I'm going to simplify it even further. X divided by 1/2 is the same as saying 2 times my x value minus pi, and my y coordinates are the same, 4 times my y value, subtract 1. And that is the mapping relationship you're going to apply to all your original sine, cosine function points to generate your new graph. So your graph will look something like this, right? And if you'll notice, and I take my highlighter, so my graph has been shifted down, it has been shifted to the left, it has been vertically stretched, so everything makes sense. And my axis of symmetry is -1. X is equal to -1 divides my graph completely in half. So everything kind of makes sense for this particular graph. Okay? So always you have to, this is what you're going to be doing for your test, analyzing those points, your mapping relationship, draw your graph, and analyze your graph. Okay, we're going to do another example. Notice this graph has no vertical shifts. That means our axis of symmetry is going to stay at the x-axis. When there's no vertical shift, the graph will be symmetrical about the x-axis. So the first thing we're going to do is rewrite our equation. So this is y is equal to 3 sine. I'm dividing both terms by 4, so I'm taking 4 out. Theta minus pi over 4. So let's go, before we analyze the amplitude, period, and phase shift, let's figure out the mapping relationship first of all. So remember, everything that affects the graph horizontally affects my x-intercept. So I have my x value, I'm dividing it by whatever my k term is. In this case, I'm dividing it by 4. And then I'm going to add, not subtract, but add pi over 4 to my x values. And there's only one thing I have to do to my y values, because there is no vertical shift. All there is a vertical stretch. Oops, don't know what I just did. All there is a vertical stretch in this case. So that 3 is the only thing that affects my y values. Y values get multiplied by 3. That means my amplitude is positive 3. So before, it took from 0 to 2 pi in order to complete one full cycle. This time, my formula is 2 pi divided by k. I have actually a horizontal compression. So 2 pi divided by 4 can be reduced to pi over 2, which is 90 degrees. So just to take a peek at the graph for a second, whereas before it was going to take a whole from 0 to 2 pi in order to complete one full cycle, right? Now I'm compressing the graph horizontally so that one complete cycle gets finished in 90 degrees. So notice, instead of one cycle being completed from 0 to 2 pi, now I can complete 1, 2, 3, 4 complete cycles from 0 to 2 pi, which corresponds completely with my k value. So like last time, my k value was 5. That means 5 complete cycles if it's a horizontal compression. Whenever you're compressing it, whatever your k value is, between 0 and 2 pi, you'll be able to complete that many cycles, okay? So it's something to look out for. Period, 90 degrees. Now my phase shift. I know I'm shifting to the right by pi over 4, which is very important when you're figuring out how to draw your graph. Okay, so we understand now amplitude, period, phase shift. We understand mapping relationship. Let's look at a step-by-step process to figure out how to draw the graph of this function.